Perfection Group training video. I'm Rob Garlick, and today we will be discussing water flow in a system, manual balance valves, and auto flow regulating valves. First, we will cover why water balance is so important in a system. Each area of a building requires a certain amount of BTUs to satisfy the heating or cooling load. Terminal units, air handlers, fan coils, or radiant systems are designed and specified to meet each space's criteria BTU load. Many different types of coils can be selected to satisfy that space load. It's a balancing act that requires a lot of thought. Things to consider: air temperatures, air side pressure drops, water side pressure drops, flow rates, and water temperatures. All these can affect equipment cost, installation times, and overall system efficiency. Next, we will discuss some water balancing devices. First, we'll discuss a manual balance valve. It's just that, it's a manual balance valve. You manually adjust it and set the stop. Systems with all manual balance valves, you must install one at each terminal unit, which I'll just use as a blanket term, and then in each branch run, at any pump, and a triple duty valve at the pump. Each branch must then be manually adjusted to ensure proper distribution through each part of the branch. Then you go through to each end user device or terminal unit and you balance those to ensure proper flow. Once that's achieved, you check your pressure at your pump and you have to adjust your triple duty valve to ensure you have the proper flow and foot of head for the pump. Manual balance valves work well in a fixed flow system. In variable flow systems, or more green new energy savings jobs, we use VFDs to control pump flow. And as you lower that pump flow, the foot of head drops, leaving some terminal units short on flow. Next, we will discuss Autoflow valves. It's just that. They will automatically adjust to maintain the proper flow, within limits, of course. Autoflows have a spring-loaded cartridge inside of the body. So as the pump changes speeds, the pressure adjusts a little bit, and you have different size orifices. As the pump increases in flow, it pushes and compresses the spring and opens more. As the pump slows down, those passages get narrower. It always maintains the flow within 10% or 5% of the given flow. Autoflows come in two sizes, typically 2 to 32 pounds of differential, which is what you read across to adjust your flow, or 5 to 60 psi. Autoflows do generally cost more, but the time to balance an overall system is much, much quicker. You install the devices, turn on your pump, and read the flow across all of your autoflows, and you're done. And then using a VFD, you can adjust the upper and lower speeds to make your minimum and maximum flow rates. Design differences. With autoflows, the system design is a lot easier. There's less of them. You put one at each terminal device and you're done. With manual balance valves, you have to put one at each branch run and each terminal device, which means you're stacking 2 pressure losses in series, which increases the foot of head loss, which means you may have to have bigger pumps. Both systems can work well if they're designed correctly. As a takeaway, again, both will work as long as they're designed properly. Upfront discussions should be used to determine whether an autoflow system or a manual flow system would be better for your application. This is a conversation between the sales group and the engineering group to determine what is best for the customer. So if we look at our system design here, you'll see that we've got a hot water system. And in our system, you've got boilers and hot water coils and air handlers. So we'll look at our breakdown here and you'll see a strainer and our autoflow and a control valve. This is a typical design that we do here at Perfection Group. If you have any questions, please consult your engineering group. Thanks for stopping by. See you next time.